Hello guys, welcome to the second video. Let us continue our journey for the practical machine learning skills, where for summary, our goal is to learn the skills which can transform, say, data, which can be in the form of videos, audios, or say IMU or text, to practical knowledge, which can help to drive, say, some useful business impact. Now, creating knowledge, like I told earlier, requires several stages. Starting with data, we clean the data, featureization, feature engineering is done, particular class of model is selected, model training is done, optimization finally, we evaluate our models, and finally, from the best one, we go into production. Now, this process is not always done in this linear fashion. This process is iterative. More and more data keeps coming. Hence, this kind of cycle just goes on. Again, this process of evaluation cleaning further is done again and again as newer class of models are developed. Production applications are also updated. As our system evolves, the users which we are dealing with also evolve. Due to this, the data which is collected from them changes over time. As the data changes, model, evaluation, everything else changes. All this is done using some language and programming. A very widely used language in literature is Python. And in this video, we'll take an introductory look at Python for ML. Python is a general purpose language, so it can be used for any number of software coding applications, web, mobile, and so on. But here our focus will be on machine learning. So most of the machine learning, as you will dive deeper into real life projects, you will realize like around 70% of the work is in data collection, cleaning itself. So a lot of work has to do with just data itself. And data exists in ML in the form of multivariates dependent variables, such as say, we have many different form of data collected. In normal, these data points can be number, text categories. A lot of work often represents this data in the form of matrices or arrays. So in Python, we are really interested in a library which can help us to do it. So whenever you're learning Python for ML, there are necessarily some libraries which we are looking into. Large work is done by libraries such as Numpy, which help us to do this matrix calculations, arrays operations so easily. It's optimized to do many of these operations in memory, out of memory, depending on the sizes of arrays. Another library which we often use a lot is Pandas. Again, a Python library represents this stream of numbers or data sets internally in its formats. Pandas data frames or data structures are very widely used, which again are very similar to spreadsheets like I'm showing it here. But it can do operations like how to handle NANs, not a number operations, cleaning, selecting only a portion of this data. Say you are interested to select only a portion of this data. These are like some of the libraries which we deal often when we are playing with the data side of the thing. Then comes other class of libraries which you are dealing. For example, after data, we also need to have some kind of libraries which can help us to train the models. And this is where, say, libraries such as sklearn comes into picture, provides a class of ML libraries. Some parts of sklearn we had seen in my previous videos on linear regression. We were using sklearn's linear regression implementation. This is where TensorFlow, PyTorch comes into picture. Both TensorFlow, PyTorch also provides capability to play with numbers, but they're highly optimized for model construction, adding different kind of models, creating different kind of neural networks. sklearn is highly optimized for classical models and so on. After all of this, there are kind of other libraries which we are after. Say, we also need to do certain kind of visualization on the data to sanity check, see what results look like. And these visualization libraries, a lot of them exist. Very widely used is matplotlib. These are often the libraries which can help you to get ML jobs, where if you know Numpy, Pandas, data cleaning processes, sklearn, TensorFlow, this is how the things are done in reality. We'll look into some of this real life through an example project, which will continue in the next few videos. The example project which we'll start will be human activity recognition, often called HAR. Human activity recognition has many practical applications, like we discussed earlier, but this is where our smart devices around us are able to, say, track us. These devices are tracking, and this tracking is done by the devices while they're connected to us. So data is often not leaving to the cloud. So this is often done on device. And this kind of tracking can tell us that a person is running or walking or jogging or doing some other kind of events. This human activity recognition is complex and challenging, but its practical applications are enormously endless. It has existed over the past decades in many different forms. We started with classical models. And these classical models often require particular kind of features, inputs on the data. So featureization was a very important stage in these models. Slowly, we have moved into neural networks. These models directly use raw data to work on and are shown to be having superior performance. Often they have their own pros and cons, and we will look into that. Most of these methods are very much impacted by where the data is coming from and how they are running. For example, this data is coming from these low resource devices. Your watch and phone have limited memory, limited compute, and also battery constraints. So the algorithms which we will look into often have to be molded depending on what is the real constraint here. We cannot create very large neural networks, so they are simpler. Or they are sometimes not even neural network, they are classical algorithms. Let me write them CA. From these simpler neural networks, we will draw some of the very cool insights, and we'll look into some of the real life data sets next. Before I move on, I'll introduce one of the library which I have been developing over the past few months. And this is all available on the GitHub. Let me do the sharing of the screen where you can find this library. I'll put the link in the video, but this library is called ML Models on Time Series. It's a collection of different algorithms throughout my research. That you will see a collection of algorithms like convolution neural networks, specifically TCNs, which are among the state of art, and can also be used for many other time series activities like forecasting, but the wide activities like human activity recognition, IMUs, cameras. LSTM networks, again, another class of recurrent neural networks which are widely used in the community. We'll start small. We'll start with basic, simpler networks in the next few videos. But as you grow, you will see that all of these data sets has real constraints, real issues in terms of timing errors, different kind of augmentations to be needed, and so on. And we'll see how practical models are developed. This was more like an introduction to Python, but later on we'll dive deep into these models and see how Python libraries are coming into create a real life system.